Dear students, firstly I will introduce myself. I myself Professor S.H. Chaubey, working as an assistant professor in electrical engineering department of the S&D College of Engineering, Noida. So, in the high voltage engineering, up till now we have seen the breakdown in the gases, breakdown in the liquids, and the breakdown in the solid dielectrics. Now, in this up to this, now we are going for the next one, that is going to be generation of high voltages and the currents. It means that from the name itself, high voltage engineering, you know that we have to study the high voltage generation of high voltages and high currents. So in this lecture, we will see the topic that is called as the cascade transformer. Why this cascade? You know, you are well known with the terms cascading, connecting one or two together. That means output of the second first is given to the input to the second. So in the cascading transformer, why it is essential to go for the cascading transformer? Because the single transformer, we can't build up a transformer above 700 kV in a single piece. It is not economical and size is very huge. So for considering this point, we are going for the cascading of the transformer. See here the cascade of the transformers. Cascade transformer. Why it is going to be used? It is going to be used for the generation of high alternating voltage. There are three methods available for the generation of high alternating voltage. First one, cascaded transformer method. Second one, cascaded transformer unit with isolating transformer. And the third one is the resonant transformer. And what happens in cascaded transformer method? Two or more electrical transformers connected in series to generate high voltage alternating current. High voltage transformers are normally used in high voltage laboratory for testing purposes. With high voltage transformers are normally used in high voltage laboratory for testing purposes. What is the principle of that one cascading transformer? The principle of cascaded excitation of a transformer, particularly those connected in circuit in which each transformer in turn is excited from a part of the step up winding of the preceding transformer. Just I have told you that from the preceding transformer, the output of the preceding transformer is given as an input to the successive or next transformer. So in the principle is going to be same, that the one output of the one transformer is given as the input to transformer. For a voltage higher than 400 kV, it is desired to cascade two or more transformers depending upon the voltage requirement. Just I have told you that above certain voltage level, it is not possible to generate or to manufacture a single transformer due to its large size. It's not also economical. So for considering this point, this cascading is going to be done. Cascading, we have seen that one part of the step of winding of the transformer is given excited from the second one. Actually, for getting such high voltage, a single transformer has to be very huge size, in which it is not economical. Just I have told you that it is not economical. Size is also going to be very huge. Transformers are usually identical, but transformers of different design can also be used. With this, the weight of the whole unit is subdivided into single unit, and transport and erection becomes easier. It is also what we will be used to transport, because not where the transformer is used, it is not generated or not manufactured at that place. It is manufactured at another place, and it is going to be transported from that place to the where we are going to use that transformer. And the second one is the erection of the transformer, how to erect that single large size transformer. So considering this point, we are going to see the cascading of the transformer. The primary of the stage 1 transformer is connected to lower voltage supply. Primary of a stage 1 transformer is connected to a low voltage supply. A voltage is available across the secondary of this transformer. An excitation winding of a first stage has the same number of turns as the primary winding and feeds the primary of the second stage transformer. The potential of the excitation is fixed to the potential of the secondary winding. The potential of the excitation is fixed to the potential of the secondary winding. The secondary winding of a second state transformer is connected in series with the secondary winding of the first state transformer so that a voltage of 2 volts, suppose that high voltage is considered as a V. Suppose the high voltage that is going to be generated is considered as a single capital letter V. Then what will be available voltage? Is available voltage of 2V double is available between the ground and the terminal of the secondary of the second state transformer. Terminal of the secondary winding of the second state transformer got the voltage of 2V between the ground and the terminal secondary of the second state transformer. Now this is the cascading equation that first stage, suppose there are 3 transformers, first is connected to second, second is connected to third. Similarly, the state 3 transformer is connected in series with second state transformer. Third state transformer is connected in series with second state transformer. With the output voltage between ground and the third state transformer is 3 volts, 3V. In the second transformer, it is going to be 2V. V is going to be the very large voltage. It is going to be 3V. It is to be noted that individual stages except the upper must have 3 winding transformers. Must have 3 winding transformers. But uppermost will be a 2 winding transformer. Now the problem is coming for the earthing. The tank of the first state transformer is earth. But the tank of the second state and the third state transformers have a potential of V and 2V respectively above the earth. Therefore, they must be insulated from the earth with suitable solid insulation. Earth is earth, no problem. But 2V voltage and 3V voltage transformers are insulated from the earth with suitable solid insulation. Through a high voltage bushing, the lead from the excitation winding and the high voltage winding are brought out to be connected to the next stage transformer. Features. What are different features? The impedance of the transformer should be less than 5%. The transformer impedance must be less than 5%. Transformer must be capable for giving short circuit current for at least more than 1 minute. Transformer must be capable for giving a short circuit current for at least more than 1 minute and is depending upon design. Now these are going to be the features of a cascading of a transformer. Now what are the advantages? Advantage is that cascade connection of a transformer, very high voltage is possible to generate at a lowest cost. Just I have told you that if you are going to erect or manufacture a single unit generator of the 400 or 700 kg, then its cost is very going to be high. It is not economical. It is not easy to erect or to transport it. So this is going to be the advantages of that. And size is also going to be compact. If single unit is going to be used, size is very large. But in this case, size is also going to be important.